The project CPSEC, presented by the Department of Information, Engineering and Mathematical Science of the University of Siena, is one of the winners of the Inail BRiC 2019 call for proposals. The goal of the two-year project is to develop a cyber-physical system for worker safety by integrating vehicle and personal location technologies and distributed sensors. The project activity, launched in October 2020, was developed under the coordination of Professor Andrea Abrado of Department of Information Engineering and Mathematics and saw the participation of the Internet of Things Lab of the Department of Engineering and Architecture of the University of Parma as a partner, coordinated by Professor Gianluigi Ferrari. The project idea starts from an analysis of the possible accident scenarios of factories with risk of major accident, as defined in the Directive Legislative Decree 105/2015, Seveso 3, carried out with the support of the company Petrolgas in Lastra a Signa, in the province of Florence, which, due to its products and the quantities of dangerous substances handled, falls under the activities mentioned in Legislative Decree 105/2015. In industry, there are many possible causes of accidents, such as broken pipes and/or machinery, overfilling of tanks, handling errors, broken vent valves in tanks, accidental falls or collisions between vehicles, and more generally, spillage of stems. CPSEC has therefore led to the development of a worker protection and safety infrastructure that integrates two functional paradigms that characterize Industry 4.0, namely, providing data collection and process automation solutions that work in real time and connect people, tools and machines. Creating end-to-end integration between the real and digital environments so that the data collected provides useful information for decision-making processes. Among the data of interest for the scenarios considered in CPSEC, the detection of leaks of hazardous substances is one of the most important. To this end, the Electronics and Electronic Measurements Laboratory of the University of Siena has leveraged its expertise in the development of gas sensors, distributed monitoring and measurement systems, sensor networks, and IoT systems to develop a microcontroller-based, battery-powered gas sensor with long-range LoRa protocol wireless connectivity that can be worn by the worker as part of this project. The device allows the detection of potentially hazardous gases, toxic gases such as carbon monoxide, and the measurement of oxygen concentration. The system has been developed using commercially available sensors that have been calibrated and optimized in the laboratory to reduce consumption and extend battery life to a full work week. The device, which was fully developed on both the hardware and software sides as part of the CPSEC project, regularly transmits data on the concentrations of detected gases and can trigger acoustic alarms in hazardous situations by connecting to a LoRaWAN gateway. In addition to gas detection, another relevant information to capture in the context of CPSEC is the position of an operator or vehicle moving in an industrial environment characterized by prohibited or potentially hazardous areas. To this end, the IoT laboratory of the University of Parma has developed a prototype capable of providing, with the required accuracy, information on the position of nodes using different IoT technologies based on possible scenarios, indoor and outdoor. In outdoor localization, position determination is based on the use of a kinematic real-time system, which is a further development of conventional satellite systems and enables accuracy on the order of centimeters through the exchange of correction messages between a base station and the target node. In indoor environments, on the other hand, position determination is achieved through a hybrid approach that integrates two heterogeneous technologies, namely ultra-wideband anchors and inertial systems. The position of the target, a worker or a monitored vehicle, is estimated using the orientation data from the inertial sensor and the information from the ultra-wideband anchors installed in the industrial environment to be monitored. The CPSEC project developed a prototype IoT node for hybrid indoor-outdoor localization using commercially available devices that can be integrated into personal protective equipment, such as reflective vests or helmets. The data on gas concentration and estimated position are then sent to a central server, which, thanks to prior knowledge of the environment to be monitored, is able to detect events where it is necessary to display alarms or warnings. The system includes a database for data collection and a web dashboard that can display near real-time hazardous gas location and detection data for each monitored site and highlight all alarms and signals for system operators.